Hello friends, this video on friction part 5 is brought to you by examfear.com. No more fear from exam. So now that we have understood the concept of friction, we will talk about different types of friction. So here we are going to talk about mainly two types of friction, that is static friction and sliding friction. So let us start with static friction. So what do you think will be static friction? So static means something which is at rest, which is not moving. So that is static. So what can be static friction? Any guesses? So when your object is not moving, so even when the object is not moving, there is a force of friction which is still acting on the object, because that force is acting on the object. That is why the object is just not moving on its own. So a force of friction which is acting on objects which are not moving, as long as they are not moving, that friction is static friction. So it is the force of friction that acts between objects in contact but not sliding with respect to each other. This is most important. That is, both the objects, they are not sliding. Now, when I say that they are not sliding, doesn't necessarily mean that the objects are going to be at rest. Because if you read it carefully, it says that not sliding with respect to each other. That means, so whenever we talk with respect to something, so the entire concept of motion and rest changes. For example, when you are sitting inside a train, okay, so do you think that you are moving? I mean, is it you who is walking or running? No, right? But the train is moving. Now, since you are sitting inside the train, so you are also moving with the train. So if somebody from outside, somebody who is standing on the platform, he sees you, for him, you are moving. So you are moving with respect to a person who is standing on the platform. But you are at rest with respect to a person who is sitting just beside you inside the train. So we cannot say that you are at rest or you are at motion, because you can be at rest with respect to one object, but you can be in motion with respect to some other object. So whenever we talk about rest or motion, it is always with respect to a particular object. So when we talk about static friction, this friction is that type of friction which acts between two objects when the two objects are not sliding with respect to each other. So with respect, when those two surfaces with respect to each other, they are not moving. So in that case, the friction which acts on those objects is termed as static friction. So we will take examples for better understanding. So let us look at this example. So here we see that this person is trying his best to push this heavy box. Now the box is quite heavy. So he needs to apply a real good amount of force in order to make this box move. So right now he is trying to apply some force, and let us suppose he is pushing it with a force of F. So F is the force which is being applied by this person to make the box move. But as of now, the box doesn't move. So this means, now if the box is at rest, the box is stationary, what does that mean? That means the net force acting on this box right now is equal to 0. That is, the total force acting on it is 0. Now if capital F is the force which is acting in this direction, that means there is some force which is also acting in the opposite direction. And what is that force which always tries to oppose motion? That force is friction. So here also there is a frictional force which is opposing the motion, which doesn't want the box to move. So this force which is acting in a direction opposite to that of the applied force, this force is called static friction. Now this static friction exists as long as the box is not moving. Now what happens is, as this person keeps on increasing the applied force, now you apply little amount of force, the box doesn't move. You increase that force which you applied, the box still doesn't move. You further increase the force that you apply. So a time comes when the box starts moving, right? Now as you keep on increasing this value of capital F, Fs, that is static friction, also increases. But static friction is able to reach only up to a certain maximum value. So a point is reached beyond which, even though capital F increases, but Fs cannot increase any further. So there is a limit up to which Fs can increase. So static friction will increase only up to a certain limit. After that it will not increase. So what will happen after that? Capital F will increase. So a point will come. Once this Fs reaches its maximum limit, after that what will happen is capital F will become greater than Fs. Now when capital F is greater, the box will start moving in this direction. So you understand what is static friction? Now when you apply a force on an object but the object doesn't move. So when the object is not moving, that means there is a force of friction which is acting in a direction opposite to the direction of applied force. So that force of friction is called static friction as long as the box is not moving. As soon as the object starts moving, then what happens? So that then comes into picture the sliding friction, which we are going to discuss in the next slide. So please remember that static friction is applicable as long as the object is at rest, and when the object is at rest, that would mean that the net force is 0, which means that there is a capital F, which is the applied force, and there is another force, that is the force of static friction, which is acting in the opposite direction. So based on this, we can say that static friction is self-adjustable. What do we mean by self-adjustable? As the value of capital F increases, the value of Fs also increases. So static friction increases its value as the value of applied force increases, but it can increase its value only up to a certain limit, beyond which it cannot increase any further. So beyond that, capital F, I'll just write it here, beyond the limit, what happens is capital F becomes more than Fs and the box start to move. And before this limit, what happens? Box is at rest. Why? Because capital F is equal to Fs. Now as you increase Fs also increases, then it reaches a limit beyond which it cannot increase. So beyond that limit, capital F becomes more than Fs and therefore the box moves. So once the box starts moving, then you do not have the concept of static friction anymore. So then you have friction which is called the sliding friction. So now let us discuss about sliding friction. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.